Here we are. Good evening, everybody. Welcome to Rabbit Hole. Still have some problems sound wise, as you can tell. Good evening, Canuck. Are you there?
Yes, I'm here.
You're here, huh? I don't know what the problems are with the sound. Maybe there's an update. Another sticking up. We just had every Thursday or every second Thursday, there's updates, and it just kicks my ass every time. I got this thing just about where I want it. Canuck, move to your left a little bit on frame. To your, yeah. You didn't move that. There you go. You keep leaning to your right there, your right shoulder. Yeah, because you kind of do this. And then you're like, blah, 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 blah. But if you got to stay on screen, can't hear Canuck. They can't hear you. What the frack? You can't hear Canuck right now? You cannot hear Canuck is what you're saying. What the hell happened? All right, let me go in there and see what it sound. Nope. Yeah, I knew something happened.
I'll have to learn sign language.
Oh, shite. Chat. Music. It's right. Everything's right. Let me go into my settings here. Music and sub. What are we using?
Well, it's like the sound is going to you, but it's not going out to everybody else, which was kind of
right.
Like music.
Right.
Thing. So I don't know.
Right. Stream. Oh, default mic. All right. That's where it should be.
Can they hear me now?
I can hear you. But they cannot. What is it, man? It was working just not 3 minutes ago. All right, let's see what the freaking frack happened here.
Well, it's almost like it isn't sending my sound and the music sound out.
Well, right. Maybe they canceled each other.
Maybe.
I don't know. But I noticed that my thing changed again. It's weird. Automatically it changed. It should be on microphone. My mic on my end. Audio mic is here. And yeah, and it should be on Bridgecast 1. Maybe that's the update hasn't happened yet. Oh man. Oh God, I get sick and tired of this crap.
Oh, it's annoying, the audio thing. What you do.
Yeah, and I can hear mine going in and out. Oh, they got him now. They said they got you now.
Oh, so they hear me now? So how did that?
I don't know. Can you you 5x5, Timmy? Talk, Canuck. Yeah. Come on, man.
I'll just talk to myself until.
There you go. This chair is like falling on me.
I'll just keep talking until somebody says they can't hear me.
Right. Well, I know I can hear you. And
we can hear each other, but
yeah. Just barely hear him. They said, I'm turning you up on your end.
under the desk.
Timmy says 5x5. Timmy's got the line in, man.
That's
You're maxed out. All right. Let me see here. I just turned them all on. Pretty close. Yeah, he's maxed out. Let me. That's maxed out there. Let me go like this. That maxes me out. Stream system. Yeah, there you go. Game speakers off.
Yeah, I'll have to shout louder, I guess.
I see it going now.
Yeah. Otherwise, I'll have to learn sign language.
I see you going. So I don't know. I got it maxed to freak out, man. Yeah, I don't know. Not fixed. Hence its name. Yeah, I got him on near max. Let's see here. I didn't do anything when I messed around.
Well, it's like it's cutting in or out or something.
Yeah, that I know. That's the mic cleanup, and I hate it. I don't know what the hell it is, but I don't know. It's not that thing.
It's
Reverse.
30% volume across the board.
Is that what yours is?
30% volume tariff. Well, that's what it's going to be. Or 35, maybe 35 for here, 30 for Europe. I'm getting confused.
Yeah, I don't know.
It changes all the time anyway.
It's the static. Yeah, I know, Eden. It's a setting, and it might be inside of. Oh man, I know I'll try this. Mm-hmm.
When you're playing the music, it sounded like static to me.
Right, I know. So disabled. I'm going to turn it off, and then I'm going to turn it back on. Submix. Apply that. All right. So they've got me now. Say something.
Can you hear me?
Yes, they got you.
Okay.
They got you now. I just flipped the script on it. All right, brother. Oh, my land.
Flip the speaker over and it works better.
Right. I don't know why there's this setting that it's constantly trying to cut out all the noise canceling. I don't have noise canceling on.
It's the cancel culture thing, so it tries to shut off everybody's sound.
Right. What a pain in the ass. What a freaking pain in the ass. All right, so volcanoes. All right, and we're going to be going down here. Oop. I don't know. What the hell? Turn off the grid.
As long as Google Earth crash.
Yeah, I don't know.
That's what I'm now. Like overloaded.
Yeah. Well, I've almost got 2/3 of the volcanoes here in Mexico, but I think what we'll do, because it uses up so many resources, you've got a link that will help us out.
Yeah, because I have the two.
Right. But what I want to do here is I want to show people what's going on right now. The reason why we're doing tonight volcanoes is for there's something strange been going on here in Mexico. All right. So as I zoom in here, all days, Okay, I'm zooming in. And this is Southern Cal, right? So we got some earthquakes in Southern Cal from looks like Long Beach all the way down Elsinore Fault, San Jacinto Fault, and on the San Andreas. We also have the White Wolf, not White Wolf, yeah, White Wolf Fault, as well as Searless Valley and Owens Valley. Also up in Death Valley and Panamint Valley at the top. Also San Francisco. We also have one little quake that why they're showing a 2.1 in Ensenada, I don't know. Also one in Progreso, Mexico, just across the border. That's at the base of the San Jacinto Fault, all right? So as you see, when I move down here, they don't have a thing. But if I open up the Mexico and share this tab instead, we're going to see some strange items here. As I scroll in, you'll notice that a bunch of, in this area right here, a bunch of earthquakes, all right? So I'm going to zoom in a little bit. Right in this area, all right? So take note of that. It's by Urupan, okay? Also, you'll see a series of earthquakes, which a couple of days ago, we saw a lot more. This only allows me 3 days. And you can see in the 3 days just how many earthquakes have been happening here. And yes, USGS is not reporting these earthquakes. Most of these are in the 2s and the 2.5s, 2.9s, so right at about 3s. And the yellow ones are in the 3s, okay? So in this area here, here's Tansatario right here, right? And as we move in, there's Pico de Tansarario. It's a 3,800 meter mountain. And I just wanted to show you that. So that's the context we're talking about. This is the reason why we're going to talk about volcanoes tonight. Also, as we zoom out and we look at Mexico, we'll see a series of lines of volcano or earthquakes, right? Northwest to southeast. Also, some that go east-west, but mainly they're going northwest to southeast, except for these over here. And again, these are going southwest to northeast. This one's going basically southwest to northeast as well. Okay, so keep that in mind, what's going on when we talk about what we're going to talk about tonight. You have that link there and ready to go, Canuck?
Yeah, do you want the Mexico one first or the Central American one?
Well, we'll do the Mexico one first because that's the big one. I mean, most of our viewers know that we often talk about Fuego, which is in Guatemala, and big quakes happening around Guatemala. Yeah, yesterday there was a 5 in Chiapas off the coast, right after that big quake that was happening in Guatemala City. Now what? There we go. The Mexican volcanic belt is what we're going to talk about. It looks like. All right, so here we go. It's a series. It's a little grouping of volcanoes that go right across Mexico. And if you remember, what Sunday it was, because we had to do it on Sunday. We talked about the three areas of Mexico. Southern Mexico was part of the Maya complex. We had the Guerrero complex, which is right here. We had the Jalisco complex, which is right here. And then we talked about how earthquakes bounce up and down this trench that goes from Jalisco all the way down to Oaxaca. And we showed how through the Caribbean plate, they translate all the way up and up this coast. Super large earthquakes. Now you can see the orientation of the subduction zone out here. It's a little bit different, isn't it? But this is a series of volcanoes that go right through Mexico City. and all the way to the Gulf of America from the Gulf of California. And it basically cut off the southern half of Mexico. There's a reason for that. And there are suppositions out there and some ideas. And I think we're going to explore some of those ideas tonight as we look. And you'll see on this map, you'll see several. These are all the volcanoes that are active right now. And gotta make sure Mom's all right. Oh, Carabola. What was she? Oh, no, she didn't. Who's sending it to me? Ernie. All right, forget it. I got to keep checking Mom because she's special right now. Share this tab instead. Here you go. You can see for those on Rumble and those on YouTube, you'll be able to see these are a series of volcanoes that traverse the central part of Mexico, coming from Veracruz all the way through Colima. There is one just north up in north of Guadalajara, probably Jalisco, but it's pretty close to near yet. We have some volcanoes that are off the coast, Barcarena and Socorro, and then there are Three Virgins, and then Pinnacle Peaks, way up in the top. We've often talked about Picante Peaks. I call it Pinnacle, but it's Picante. Picante sauce. What? New York City. Anyway, El Chichon down here in the south. And I'll try to save this image, try to get it enlarged for you. And that way we can see that much larger. What else? For those on YouTube, this is the area that we're talking about tonight. We talked about the trench down here. We talked about this area through here of volcanoes. We talked about the Mayas having this part of Mexico, and then Guerrero, this part of Mexico, and then the third block being Jalisco, then all North America's up here. Kind of where above this line is North America. Think about it. If this was that line for North America, and all this is accreted terrains, there's a separation here, and I think that's what we're going to talk about tonight. So, I'll lead you up there and go ahead and say what you have on tap for that.
Yeah, I'm just going to read the first 3 parts of this thing because it's pretty straightforward, just explaining where it all is and stuff. And then after that, it gets more complicated because it gets into the plate, their different views of how it evolved there and why the volcanoes are there. So it gets more complicated the farther we get into it. So I'm just going to do the simple part for right now. And then we'll get into the other stuff after. The Trans-Mexican Volcanic Belt, also known as the Trans-Volcanic Belt, and locally as the Sierra Nevada Snowy Mountain Range in Mexico, is an active volcanic belt that covers central southern Mexico. Several of its highest peaks have snow all year long, and during clear weather, they are visible to a large percentage of those who live on the many high plateaus from which these volcanoes rise. The Trans-Mexican Volcanic Belt spans across central southern Mexico from the Pacific Ocean to the Gulf of Mexico in there, which is now America, between 1830 degrees north and 2130 degrees north, resting on the southern edge of the North American plate. This approximately 1,000 kilometer long, 90 to 230 kilometer broad structure is an east-west active continental volcanic arc encompassing an area of approximately 160,000 square kilometers. Over several million years, the subduction of the Rivera and Cocos plates beneath the North American plate along the northern end of the Middle America Trench formed the Trans-Mexican Volcanic Belt. The Trans-Mexican Volcanic Belt is a unique volcanic belt. It is not parallel to the Middle American Trench. and many of the main stratovolcanoes are positioned obliquely to the general position of the arc. In addition to the physiographic complexities, igneous compositions vary. Dominant subduction-related products contrast with intraplate geochemical signatures. The many intriguing aspects of the belt have spurred several hypotheses based on a typical subduction scenario, interplate leaky transform faults, mantle plumes, continental rifting, and jump of the eastward Pacific rise. These features are partially related to the reactivation or early fault systems during the Trans-Mexican Volcanic Belt's evolution. The main brittle fault systems' geometry, kinematics, and age defined a complex array of what could be multiple factors affecting the deformation of the belt. It exhibits many volcanic features, not limited to large stratovolcanoes, including monogenic volcano cones, shield volcanoes, lava dome complexes, and major calderas. So it's like a wide variety of stuff. Prior to the formation of the Trans-Mexican Volcanic Belt, an older but related volcanic belt, the Sierra Madre Occidental, occupied the area. Resuming in the Eocene post-Laramide deformations, subduction-related volcanism formed the Sierra Madre Occidental silic volcanic arc at a paleosubduction zone off the coast of Baja California before the peninsula rifted away. From the late Eocene to the middle Miocene, counterclockwise rotation of the volcanic arc. So here we are, more counterclockwise.
Counterclockwise, yeah.
Transitioned the once active Sierra Madre Occidental to a now active Trans-Mexican volcanic belt. By the middle Miocene, the transition from the silicic to more mafic compositions was complete and can be considered the beginning of the Trans-Mexican volcanic belt. Due to the orthogonal orientation of the Trans-Mexican volcanic belt in relation to the trend of Mexican tectonic provinces, its pre-Cretaceous basement is highly heterogeneous. The Trans-Mexican volcanic belt east of 101 degrees west rests upon Precambrian terrains assembled into the Wakakia microcontinent and on the Paleozoic Mixteco terrain. West of 101 degrees west, the Trans-Mexican volcanic belt resides on top of the Guerrero composite terrain, a makeup of Jurassic to Cretaceous marine marginal arcs, which are built on Triassic, early Jurassic siliclastic turbidites. Assemblage of these basement rocks results with a thickness of 50 to 50 kilometers east of 101 degree west and 35 to 40 kilometers west of 101 degrees west. So it's thicker on the eastern side, the crust, and a little bit thinner on the western side.
Makes sense. Makes sense.
Now, the next section talks about the plate evolution. It's pretty straightforward, and it talks about like what is moving and everything else.
Right, that's what we need to know, yeah.
Yeah, the subducting plates originated from the breakup of the Farallon plate at approximately 23 million years ago, which created two plates at equatorial latitudes, the Cocos plate and the southern Nazca plate. The Rivera plate was the last fragment detached from the Cocos plate, becoming a microplate around 10 million years ago. The small plate is bounded by the Rivera fracture zone, the East Pacific rise, the Tamayo fracture zone, and the Middle American Trench. The larger Cocos plate is bordered by the North American plate and the Caribbean plate to the northeast, the Pacific plate to the west, and to the south by the Nazca plate. The Cocos and Rivera are relatively young oceanic plates. 25 million and 10 million, that are subducting along the middle American trench at different convergent rates. Rivera is close to 30 millimeters a year, and Cocos is 50 to 90, depending on which part of it you're looking at. Commonly found subduction-related rocks, such as calc-alkaline rocks, volumetrically occupy a majority of the trans-Mexican volcanic belt, but smaller volumes of interplate, like lavas, potassium-rich rocks, and adacites are associated with the area. Middle Miocene adacitic, more felsic rocks are found farthest from the trench and along the volcanic front of the central trans-Mexican volcanic belt during the Pliocene Quaternary. It has been suggested that slab melting contributed to the adacitic imprint on the trans-Mexican volcanic belt, prompted by the prolonged flat subduction of the Cocos plate. And then the next section in here shows all the different, they show like how the plates are subducting and everything, and how they think it formed and how it moved along that.
Right. I think that's kind of important to see how the plate is working. And I put the volcanic evolution of trans-Mexican volcanic belt up so that people can see the volcanic evolution and changes in composition over time. Early late Miocene, the belt of Cocos Rivera plate began subduction beneath the central Mexico. That's the first part here. Number two is a late Miocene to Pliocene, sorry. The slab tear begins to propagate west to east across the back of the northern area of the belt, allowing the asthenospheric heat and to generate a mafic episode. Three, the latest Miocene, early Pliocene, was the onset of a more silicic volcanic generated by the flat slab subduction, which is interesting in itself. Flat slab subduction is, we've talked about this many times. Flat slabs like this, this portion of the flat slab continues for a long distance. There's the asthenosphere. As it subducts, it stays under there for a long time. A lot of people, scientists, believe that that's Southern California, that it has a flat slab underneath it, and so Mexico has the same kind of thing. So, but back to what we're talking about here. So you can see in this one here how it's a flat slab. Yeah, and then the later years, late Pliocene to Holocene, which is more current, characterized by slab rollback, sending the volcanic arc trenchward to the present day position. And how that happens is the rollback is generally, this rollback is where this part of the plate slides backward. Let me see. I think you all can see that. Make sure. Yeah. The bottom part here. Save this page. Kind of sucks. A PDF file. I guess it's a PDF file. I didn't know that. Can I download it? Yeah, I can. And then maybe I can.
Yeah, it kind of shows how it's subducting, so you can see how it got to the way it is now.
Right, I could zoom and share this tab instead. Yeah, I'm not able to share those, but I can kind of here on Twitch. There you go. This one's sliding back. You can see the little bubbles are creating the volcanoes, right? The flat slab. Generally, under a flat slab, they don't create volcanoes because there's no water and it's too close to the surface crust. But as it begins to drop, that's when it starts to heat up, and using the water to create steam, which breaks the rocks, which creates magma, and it creates volcanoes. So that's kind of how it works. So this is a early time period in the top part. You can see that there are volcanoes, and then they stopped, as you can see right here between the two areas, because the slab was kind of not It was more buoyant. It stayed up, and before it dropped down, and then it began to slab off. I don't think they have evidence of it breaking off like it did in the Pacific Northwest, or up by California, Oregon border, but it sounds very similar. And this is, you can see the volcanic arc right here. Let me see on yeah, you can see it over there. Good. So this item right here is what we're talking about, and the flat slab we talked about. But this is the current modern day thing, and it is rolling back, and there is volcanoes as a result. So interesting that Eta A, I guess, is where they're saying that the slab is going inland, and you can see 11 time period, 7 to 3 million years, 7.5 to 6.5, 9.9 to 7.5 million, 10.5 to 9, 11 to 9. The difference in time periods. The youngest being on the Mexican side of things. I mean, Gulf of America side of things. Well, it's all Mexican. There's the capital, by the way. So that's kind of the geology of the area. Does anybody have any questions that kind of, or thoughts they can want to put out there, Eden or Walleye King or Timmy? And that has nothing to do with magnetic reversals. This is all fault and plate movement. Correct. Yeah, it's all fault and plate movement. The idea of plates moving along tracks, so to speak, like a train tracks, that is magnetic, and we're going to be getting into that in the near future, quite detailed, because we got some ideas on some things and how the plates are following the lineaments. And they may be making the lineaments, or these lineaments may be, which is an electromagnetic connection with the core and away from the core. We'll just leave it at that. What else we have?
Yeah, and it talks about in the same line, it gives like the names of some of the volcanoes going from.
I don't know why there's so much damn noise. It's on my end. Could be this microphone going bad.
Yeah. So I'm just going to read the parts for that where it talks about where it is, the geography, and the height of peaks, the main ones. From the west, the Trans-Mexican Volcanic Belt runs from Colima and Jalisco east through northern Michoacan, southern
Michoacan.
Michoacan, Guanajuato, southern Querétaro, Mexico State, southern Hidalgo, the Distrito Federal, northern Morelos, Puebla, and Tlaxcala to central Veracruz. The Mexican plateau.
So basically, it goes from right here's Veracruz all the way across Puebla, Mexico, up through Morelia, all up through Guadalajara, Zamora, Hidalgo right here, Acatlan, and up to Puerto Vallarta. So it's down this line right here. So follow that through all the way at that angle. It is a northwest to southeast view, but it's a sharp angle. It's not very it's very shallow, I should say. It's it's not like 90 degrees. So go ahead there, bud.
Yeah, so the Mexican plateau lies to the north, bounded by the Sierra Madre Occidental to the west and Sierra Madre Oriental to the east. The Cofre de Perote and Pico de Orizaba volcanoes in Puebla and Veracruz marked the meeting of the Trans-Mexican Volcanic Belt with the Sierra Madre Oriental. To the south,
which is out here to the east. So right here is Puebla, and this is the Sierra Oriental. There's the Sierra Madres over here in the west, and just past Mexico City is Puebla, and this is where they meet, right down here.
Yeah. To the south, the basin of the Balsas River lies between the Trans-Mexican Volcanic Belt and the Sierra Madre del Sur. This area is also a distinct physiographic province of the larger Sierra Madre system physiographic division. The Sierra de Ajusco Chichinatzen, that's quite the name, also forms part of the belt. Now the next section talks about the peaks. The highest point, also the highest point in Mexico, is Pico de Orizaba, 5,636 meters, 18,491 feet. Also known as Citlaltepetl, that's quite the name. Located at 19 degrees 01 degrees north, 97 degrees 16 west. This and several of the other high peaks are active or dormant volcanoes. Other notable volcanoes in the range include from west to east, Nevado de Colima, 4,339 meters, 14,236 feet. Paracutin, 2,774 meters, or 9,101 feet. Nevada de Toluca, 4,577 meters, 15,016 feet. Popo, 5,452 meters, 17,887 feet. Iztaccíhuatl, or however they say it. Some people call it Izzy, so that's what I'm going to call it because it's easier to say. 5,286 meters, 17,343 feet. Matlalcuatl, 4,461 meters, 14,636 feet. Cofre de Perote, or Perote, I don't know how they say it, 4,282 meters, 14,049 feet. And Sierra Negra, a companion of the Pico de Orizaba, 4,580 meters, or 15,030 feet. And then it talks about what grows up there. The mountains are home to the Trans-Mexico Volcanic Belt pine oak forests, one of the Mesoamerican pine oak forests sub-ecoregions. The Trans-Mexico Volcanic Belt has many endemic species, including the Trans-Volcanic jay. Volcanic ash makes soils in the region very fertile, which, especially coupled with elevation making tropical climate milder, has led to high human population densities in the belt that now sometimes strain the environment. So it's wild stuff.
Agreed, bud. I'm looking at the volcanic access, which basically there is a couple of different plates down in there. The Rivera plate, Arizozo plate, and then the Cocos plate. The Arizozo is this little area right in here. Right here, actually. The Rivera plate is up here. Goes right through here. And it comes down probably to this section here. So this is the Arizozo plate is right here, right? So Colima and Michoacan, there's a little plate right here, and then this is the Rivera Plate right here, and then the volcanic axis goes right through Guadalajara, Morelia, Mexico City to Veracruz. So that's kind of, and the peaks, he just listed a bunch of the peaks, which is pretty insane to there are more taller peaks than in America. I think the only peak we have is up in the former Denali or Mount Whitney, or is it Mount Whitney, or is it, I don't even know which one that's called. Denali was named something, they changed it again.
Yeah, it was Denali before, but now it's Whitney again.
Is it a Whitney again? Okay.
Yeah, it was Whitney, then they changed it to Denali, and now it's back to Mount Whitney.
Right. So, what did they say?
Because Denali is the native name. Native people name.
Yeah.
After the Denali Fall.
Well, this area is super, super interesting due to just outside Mexico City, they've got volcanoes that are active that are 17,000 feet up there. Popo is up there, Popocatépetl, and then there's a couple of other ones which are more dangerous to the city, but they're not as active as Mexico, as Popo is. So some of them, they consider them to be dormant.
Popo, Colima, and Paracutin are actually the most active, if you want to simplify it. Like right now.
Right. And we've all seen the share this tab instead. This is the list of volcanoes. There's a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 21, 2, 3, 4, 5, 6, 7, 8, 31, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 42. 3, 4, 5, 6. 46 volcanoes in the Trans-Mexican Belt. It's about 1,000 kilometers long, and some of them are pretty darn active. There's a 1953 cinder cone that was active, and I can show you that one. Share this tab instead. It's offshore, Barcina. And then a 1982 El Chichon, which is a very dangerous volcano. And it's down in Chiapas. El Chichon's 82 eruption was the largest volcano disaster in modern Mexican history. Explosive eruptions and high sulfur and anhydrite bearing magma destroyed the summit, and lava dome were accompanied by pyroclastic flows and surges that devastated the area extending about 8 kilometers away. Total 9 villages were destroyed, killing 1,900 people. A new 1 kilometer wide, 300 meter deep crater now contains an acid crater-like lake. Yeah, pretty crazy. The landscape was covered in ash up to 40 centimeters in depth, over 24,000 kilometers. That's pretty damn crazy.
And before that, they didn't think it was active. So this was a surprise to them.
Yeah.
Which was like 3 years before the big Mexico City quake. So.
And El Chichon is down here on the bottom, but what else we have? And that was in 82. 2019, Colima erupted, which is one of the volcanoes that both Canuck and I watch very regularly. It's a 12,500 foot a mountain.
When it erupted in 2019.
2019, yeah. 2019.
It doesn't get the date.
Yeah, hold on, I'll get you it. Let me see. 2000.
Because it went off. It went off in 1872 before Owens Valley too.
Yeah, November. It erupted in 2014, 2005, Colima 2017, January 18. Yes.
So that would have been before the two big quakes in Mexico.
Yeah. Okay. So
that's interesting. So it's kind of acting up.
Yeah. Right.
Big quakes either in Mexico or SoCal or Central California.
Let me see if I can see when it last erupted here. It's built upon a 2,500-year-old debris avalanche from volcanoes to the south. I should have said instead. So you can see what I'm looking at.
When I looked it up before, ever since I think 2013, it's been off and on. It doesn't do it every year, but
Yeah, I mute myself because it's my microphone. It's not doing well. Bugs alert. Uh-oh. Don't send. Something crashed. I don't have any idea what crashed.
the whole thing just all went off.
What's that?
The whole thing, because the site just went down.
Shit. Well, we're still up. We're still up on the other channels. Oh, look at that. There's another update. Look at that crap. A forced update for OBS.
So not the
God bless America. That just irks me, dude. Well, we're still okay. So, El Chichon in 1982, 2019? Stream has started. Yeah. What a pain in the ass that is. Looking at Colima, it doesn't give me an exact date on 40 times. It has erupted 40 times since 1576.
Yeah, I think I read that too.
Zapotepa is also a name of Colima. Crazy. 26th most prominent peak in North America. It is part of North America. Yeah, you're right. The largest eruption, May 24th of 2005, was large. It erupted again in 2014, on July 10th of 2015. And then another explosion on January 18th of 2017. So
it is like off and on. Because I think I read about if they continue, or they say that it's like continuously erupting, but it has like episodes. Well, like
right.
the way
we've seen it where it would smoke, but it didn't really erupt.
Yeah.
There's a 1952 Michoacan Guanajuato volcanic field that erupted in 1952. So Mexico was pretty busy in the early 50s. Here's an Paracutan in 1952. That's a cinder cone. That's the one in a guy's backyard. Paracutan. Yeah, so, it's 2,800 feet now.
Yeah, so 52 would have been the year of the Tehachapi quake.
Tehachapi? Yeah, Tehachapi, yeah.
So all that stuff was happening down there that year.
Right. It's kind of funny how things are related, right? My camera's even froze. Wow. All right.
It's really messed it up.
Crazy. Just freaking crazy. Dun, 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 dun.
I don't know if they're hearing me or again or not.
I don't know, man.
We may be just talking away.
Yeah, that's okay. The other sides are fine. It's only was Twitch that crashed. It's up now. So, what else we have on 19? Yeah, Paracutin. 24 Popo. That's the latest eruption. It's slowed since. 1994 Socorro. That's offshore. And there's Tacana. Second highest peak in Central America.
Socorro's out there. Well, that was the same year as Northridge.
Yeah, 1994. Yeah, wow, check that out, right? Tacana is closer to the shore, western shore, in of Chiapas. All right. So it's at the very southern end of Mexico. So it erupted as well in 1986. Tacana did, and that's pretty much at all that's close. Now there are a bunch of earthquakes or a bunch of volcanoes that gone off in 1700s and 1800s. We can have fun by pulling up one, a large. There are different kinds of volcanoes as well. Shield volcanoes, calderas, cinder cones, composite volcanoes. Also, the big boys, like Popo, Popocatépetl. It was a composite volcano. Interesting. Oh. It's not a strato, it's a composite volcano. I don't know what the hell the difference is.
Yeah, in 82, when the other one blew up there, Chinchon or whatever it's called.
Yeah, Chinchon.
I was reading about it, and it messed up. What was it that year? El Nino.
Yeah, okay, composite is a stratovolcano.
It messed up El Nino that year, I guess.
Yeah. What year was that?
1982.
Yeah, 82 was a very, very, very strong El Nino.
And it put so much stuff up in the atmosphere to actually.
Kansas and Arkansas flooded in 1994 as well. Yeah. There's some interesting data that came forth recent. That is conjecture still, but they're studying the effects of Kernville or Caryville, whatever it's called. I think it was Kernville, right? Kerrville, like dog, yeah. Kerrville, that were both the, solar eclipses crisscross. It's right there. Also, not solar, but explosions of not planets, but stars that happened back in June. That's supposedly affecting our planet too, and it has done so in the past. There's a history of that. So there's a extra solar connection as well as a solar connection, as well as stupid ass connections of people knowing that it floods. Doesn't flood all the time, but it does. So,
Yeah, it did in 1935, in the 50s, and the 80s.
Yeah. And it just so happens, we had a very weak La Nina, and I don't think we're going into El Nino. I'll know more tomorrow when the guy does his report.
the geomodels guy had a thing on it today where he explained how like all the little streams came down off the hills and how all the water comes down all into that river.
Yeah, but did he explain that that area got excessive rain because it's an unusual event? It's an anomaly that doesn't happen all the time. But yeah, we can understand the mechanics of it flooding the area, but that area specifically and another area by the Carolinas both got immense amount of rain, and at the same time period that we're in right now, and great, you know, thoughts. And I don't particularly like the guy that I watched today. He had a guest. That's why I watched the guest, because the guest had something interesting to say. And presenting it was a little difficult for him, but because of the interruption. But it's okay. You know, it is what it is. We'll know more about it because we're going to talk about that kind of stuff too. We're going to bring some of that into what we're talking about because of the limit ideas, the electromagnetic connection within the planet, the way it works. It's all part of the same system. We can't exclude it. It may not be, 10% of creating earthquakes. It may be a fraction of, a half a percent, but it's still part and parcel of the whole system. And we're constantly, Canuck and myself, constantly are trying to bring to you, the listener and a viewer, a composite of data to synthesize, and it's a tough word to say, and allow you, the viewer and listener, to do your own research. So we're trying to bring it to you the best we can in our ideas. So in Central America, so there's a divide in Central America, and it's that divide here is due to the plate tectonics and how everything is built. When North America went over the East Pacific Rise, it took off, Baja California, and created the Basin Inner Range. So, yeah, it's just obvious now something wants to move. Oh, yes, sir. Yep, no doubt, Eden. And thanks for hanging out with us this evening, for those who are still with us. San Diego Dan is out there. Simply Sue, Eden, Vampy, Flutter Girl. They're probably just rapping with each other anyway. Susan, Timmy, and Walleye King. It will go when it wants to, and it's ready. Yeah. Yeah. I mean, again, we're not forecasting. We're only telling you how what the historical record conveys to us. And by doing the research, we can see that through plate tectonics, that's what's creating earthquakes. And, it's interesting, to say the least. I don't think so.
And we can do the wiki for the Central America too.
Okay, go ahead. Go ahead, bud.
It's not as long as the other.
Yeah, my camera is out, so it crashed. Everything crashed on me. I don't know what it was. All right, so dang, 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 dang. Share this tab instead. Show this on here. There you go. Central American Volcanic Arc. Cava is a chain of volcanoes which extends parallel to the Pacific coastline in Central American Isthmus, from Mexico to Panama. This volcanic arc, which has a length of 1,100 kilometers, or 680 miles, is formed by an active subduction zone with the Cocos Plate subducting underneath the Caribbean Plate, the North American Plate, and the Panamanian Plate. Volcanic activity is recorded in the Central America region since the Permian times. Numerous volcanoes are spread throughout various Central American counties or countries. Many have been active in the geologic past, varying in intensity and active according to different factors. Say Wikipedia here. The cava is formed by the subduction of the Cocos Plate and the Nazca Plate underneath the North American, Caribbean, and Panama plates. Its structure is heterogeneous by the combination of the oceanic and continental crust fragments. Define four domains of cava: North American Plate, slivers, continental crust, the Guatemalan suture zone, the continental crust, continental blocks of the Caribbean Plate, and Pacific affinity or accreted complexes of the ocean crust. Interesting how everything being accreted is really what's going on.
Yeah.
You know?
It's all smashing together.
Yeah. The Cocos Plate is located along the western edge of Central America. Let me see if I can get a better image for you here. And myself, I gotta be able to see which one. I know I had them, but it depends on which computer I'm working with. Here we go. Here we go. We have it. And I'll share that with those out there in the other locations. Which one is it? That's that one right there. All right, so I'm going to zoom in for you and show on stream. And there you go. All right, you should be able to see that. Oh, yeah, you see it nice. All right. You go back to here. Yeah, you're seeing it. Good. The Caribbean, where are we at? Right here. The Cocos Plate, which is this blue one here, is located along the western edge of Central America. The latter is along the western edge of the Caribbean tectonic plate and can be split into two distinct regimes. These regimes are demarcated by roughly the Costa Rican-Nicaraguan border and can be differentiated by different tectonic histories. Each respective area has its own history. The southern portion is part of the magmatic arc, while northern one is associated with the several active margins, which I think are pretty interesting, the active margins. And different types of faults also coexisting with each regime and further serve to differentiate the northern and southern regions' geologic and tectonic histories from one another. The magmatic record of Central America begins with the Permian Triassic, which is about 283 to 215 million years ago. Granites and gneisses are of arc affinity formed on the western margin of Pangaea. Second episode comprises the Jurassic to the Barrison Continental Rift volcanism associated with the opening of the Proto-Caribbean and Gulf of Mexico. The third pulse includes the alkaline volcanism and intrusive rocks ranging from the Aptian Y-Persian times 124 to 50 million years ago, which is kind of key to a lot of events. Okay, 124 to 50 is really key. 50 to modern day is really key as well. Present continental slivers of the Caribbean Plate, the MCOT and the Santa Elena and Nicoya units. Between the second and third episodes, there are Jurassic Cretaceous Island Arc volcanic rocks of Paleo-Pacific origin that got accreted into the zone, and the Mosquito Composite Oceanic Terrain, the MCOT. A fourth pulse is only located in the Talamanca unit of the Panamanian plate of age Maastrichtian Bardonian, which is 71 to 39 million years ago, and Malay Theolitic composition. The fifth and sixth magmatic pulses, the Oligocene and a Pliocene and a Quaternary, defines the cava, both parallel to the Middle American Trench. Interesting.
So it's talking about the different
Five
rocks.
different pulses of geologic history along these areas that we're seeing, and all the way stemming back from, call it near 300 million years ago until current day. All those acronyms that I put up there are really key. Central American Volcanic Arc, that's the cava. So, take your notes when you go out and you study these things, and remember that we're setting the stage for further studies. So when something comes up and we start to research it, it becomes a little more clear of how these plates are operating, how they move, what happens along the plate margins, and the volcanics. There are several volcanoes here in Central America, in the Central American Volcanic Arc. And we can give you a stinking list of them, but they're a ton. Oh my gosh. It's just there's a lot.
Well, everybody knows a bunch of the names of them.
Yeah.
That's
Yeah.
more than-
Yeah. Right. Yeah, and just in Guatemala, there's Taramuco, Santa Maria, Chichabal, Tamalan, Atlan, Fuego, Volcan de Agua, Pacaya, which Pacaya a couple of years ago erupted quite a bit, and Chingo. And El Salvador's Apaneca Range and Chinchopec, or San Vicente, Chaparistique, or San Miguel, Chinameca, and Conchagua in Nicaragua, Consigua, Consigüina, Tilica, Cerrero Negro, Montemaro, Apoyaque, Chitepe, Mombacho, and Concepcion in Costa Rica, Orizo, Rincon de la Vieja, which always erupts. It's erupting now, but it's not making the news because nobody cares about them. Miravalles and Areno and Barva Tarabala and Irazu in Panama. In Panama, there's two, Baru and La Yugara. Often we talk about what is it? Rincon de la Vieja, also Pacaya Fuego, and Santa Maria, which is also
Santa Maria
Santa
had
Guido.
a big eruption in 1902 that was gigantic, and that was the same year that La Soufriere was going off in Mount Pelée, in the Caribbean. And they were like that whole year. And there was a big quake in Guatemala at the start of the year, 1902. So that's pretty interesting.
Yeah.
Because it talks about the Santa Maria one in the wiki.
Right.
Like just one it's had there.
And there's another one which changed our world. It's called Ilopango. And I think I'm gonna go look that one up. Little Ilopango here. Ilopango. Is it erupt? Lake Ilopango is in San Salvador, and is a crater lake which. Let me see. I just want the volcano. Yeah, it's in Salvador. It's huge. La Paz and Cruzlan caldera, which contains the second largest quake in country, immediately east of the capital of San Salvador. Any surplus drains via Jobal River into the Pacific Ocean. Ilopango that has an airport, blah, blah, blah. Eruptive history. 4 major diacetic rhyolitic eruptions occurred during the late Pleistocene, Holocene, and producing pyroclastic flows and tephras that blanketed much of the country and did some really crazy stuff. The caldera collapsed somewhere between 410 and 535 CE. I think that's post-Christ, right? At 532 is the actual date, based on radiocarbon data, which produced widespread pyroclastic flows and devastated the Mayan cities. However, a team of scientists concluded that the volcanic eruption might have happened in 431 based on volcanic shards taken from ice cores in Greenland, levels of sulfur recorded in iron cores in Antarctica, and radiocarbon dating in charred tree found in volcanic ash deposits. The eruption is estimated to have produced about 19 cubic miles of eject. During several times more, the 1980 eruption of St. Helens, which puts it at the rating of 6 on the volcanic explosivity and makes it one of the biggest volcanic events on Earth in the last 7,000 years. Fallout from the eruption column blanketed the area of at least 10,000 square kilometers, with a pumice and ash to a depth of 50 centimeters or 20 inches, and nearly 2 million kilometers square at depth of at least a half a centimeter or 20.2 inches, which would have stopped all agricultural production in the most severely affected areas for decades. It is also theorized that the eruption and the subsequent weather events and the agricultural failures directly led to the abandonment of the Teotihuacan by the original inhabitants. It is also hypothesized that the eruption caused the extreme weather events of 35 to 36 in Europe and Asia, but some people say it's unlikely. But hey, whatever, because they argue about the 431. Later eruptions formed several lava domes within the lake and near its shore. The only historical eruption, which occurred in December 31 in 1879 up to March 26, 1880, produced lava dome and a VEI-3. The lava dome reached the surface of the lake, forming an island or islets known as Isles of Quamadas. So that little booger, I'll tell you, in El Salvador, which is about where the arrows are, created some worldwide issues with another volcano. I think the other volcano was what, up in was it in Iceland, or it was up north somewhere, right? Yeah, I think
because it's showing up in ice cores.
Right. Yeah, the volcanic winter of 536.
Yeah, so now they think it was a different volcano that did it in 535, 536,
Mm-hmm.
but they haven't said which one it is.
Right.
They're thinking the latest stuff from 2024, something up here now. They said maybe one blew up in North America somewhere.
Right.
Based on what's in the ice cores.
there's several major volcanic eruptions that happen throughout history. The year without a summer in 1816 um, vul- uh, is pretty crazy. You know, um, there volcanic events as well as uh, space events. I don't know how you call it, extraterrestrial events. Um, in 1812, La Soufriere erupted. Um, there's a mystery eruption that happened in 1808 out in the ocean, southwestern Pacific. Awu happened in the, in 1812, 1813, Tsuno Zajima, and 1814, Mayon in the Philippines. All of those happened, and that created a year without a summer. Uh, that is pretty critical to partial of what's going on around the world. And do you remember the story of the plague and how it was created and all of that? And um, yeah, Hecla erupted in 1200 BC, and yeah, in the winter of 536. Possible Krakatoa and Ilopango in Salvador. Could have been Krakatoa. That's I didn't want to say it, but I just read it. Pikachu and between North Korea and China, Heaven Lake eruption of Pikachu Mountain in 969. Um, uh, Mount Ranjani, 1257. Fall of Constantinople in 1443, mystery eruption. Helped bring down Constantinople. Peru, Hayaputina, 1601. The Russian famine of 1600s as a result. Lackady in Iceland, in 1783, in 1984 or 1784, right when um, Washington was crossing the Delaware, was due to that. It was a freak storm, freezing things and super cold. Many guys died and lost their limbs. 1883 of eruption of Krakatoa. 91 minute Mount Pinatubo. Temporary cooling in the United States, particularly in the Midwest. There's still no data right now for what happened on Hunga Tonga Happy Eye. I know it's gotten a lot warmer lately, but
So the newest on 536 says that it was an Iceland volcano, but they don't know which one. 2024, I'm looking at
right,
where they were trying to figure out which volcano it was.
right. Like I said, what I heard was it was up in Iceland or Krakatoa, Ilopango, wiping out the Mayans, and Ilopango could have done twice. If you're only 10 years apart, how are you going to tell 10 years apart?
Because they said there was another big eruption, 539, 542. So.
Yeah, exactly. 1458, there's another eruption, volcanic, but they don't know where, but it affected the world. The Dalton minimum period is a low solar activity from 1790 to 1830, right? The mini ice age, right? Global cooling, discredited 1970 hypothesis or imminent cooling of the earth. Hey, we went out the little ice age, the climatic cooling after medieval warm period, 16th to the 19th centuries. We saw the effects of that. The Tambora culture, lost village culture in Sumbawa Island, Indonesia. These are events of what volcanoes can do to the world. You get one super big pop, like we just had a 63,000 foot explosion However, it didn't seem to pop out a lot of tephra. It just erupted to that height. Just little Toby, last week or the week before. And then again, another pop, some 50,000 feet. So, and that's, north of Timor in the, just south of the Flores Sea. But 63,000, that's the same height as Hunga Tonga Happy Eye. But Hunga Tonga Happy Eye is now thought, last I read, thought bigger than Krakatau's eruption of 1883, I guess what that it was, 1886 or something like that. I don't know, 1800s. Krakatau. But
Yeah, 1883.
Is 83, yeah. The Year Without a Summer is an interesting study in 1816, and due to volcanic activity. I think that one was due to what was going on in Iceland myself, but it might be a ultra Plinian eruption occurred. It was Tambora. Summer temperature anomaly compared. I want to stop short of going too far. That's far out stuff we can talk. I don't know what the latest volcanic activity up there in Iceland is, but right now in the news, volcanically speaking, Ibu and Dakono are still up around 7,000 feet. Kirishima, 6,000, which is just north of Sakurajima. And we'll talk about that tomorrow. Or no, we won't. We'll talk about it on Monday. Popo is just farting in the wind. Little Tolo, 6,000. It's down there near above Timor. Dakono, yeah. Sakurajima is doing 8,000 feet. Remember, Sakurajima and Kirishima are very close, and then Suwanozajima is offshore. We did that study on Nankai Trough, and we had all kinds of technical issues, but I'll clean up those videos soon enough. Getting the other system set up for that. Ibu is still doing. Go ahead.
No, I'm ready.
No. Kirishima, nothing here. Popo, 20,000. It's nothing. I'm looking at what's made the news the last few days because we haven't bought on here. 15,000 is that's normal. On Friday, Sunoza did 6,000. Simiru, 5. Little Tolo, 18. No, Little Toby did 18 on Friday. That's the one that blew to 63. It's in a bunch of islands east of Bali in Indonesia and just north of Timor. And Ibu. Raung volcano there on Sumatra. No, Java. It erupted 14,000 on Friday. And Simiru, which is about 20 miles away, it's erupting too, about the same. Toby, 18. Yep, Toby's been doing 18. And Simiru is 15. Yep, out of a 12.3. So Japan's rock and rolling. Indonesia's rock and rolling. Popo's quiet. Fuego in Guatemala is quiet. There is a bunch of huge movement that's happening underneath the volcano arc there in Mexico, but nothing has erupted yet. Mulrapi did 14 on Friday as well. Yeah, I'm not seeing anything else. We did have an M2 today. Did you know that?
No, I never looked.
Yeah, we had an M2. Um, that um, that new sunspot that came over is really active. It's beta gamma delta. It has X class potential. So solar wind is at 646. So an M2 and a C5 flare today. Um, and KP is unsettled right now. It's a little above 4. Huge coronal hole. I mean, sure, we're going to get more talking heads about the coronal hole because it just, almost a third of the sun. It's a little bit less. Might pick up some more wind, the 13 to the 15. That's tomorrow. 55 chance for an M, 5% for an X. That's about where we're at. Yesterday that 1,200 foot rock flew by us at about 4 million miles away, 5 million miles away. Yeah, 1,200 foot rock, out in space. Between us and Mars, dude, Mars is a lot further away. But outside of that, right now there's nothing to be said of what's happening in, volcanically speaking, in the area we're talking about here in Central America and Mexico. But there is vibrations and areas that we should be aware of, and only the Mexico people talk about it. And what I'm saying is here, Morelia, that earthquake or that volcano that came up, 2,800 foot out of the guy's backyard in 1952. That's vibrating right now. Also, a line of earthquakes going right into Colima volcano. We do have some offshore. We have another focal point here in central Mexico, in Oaxaca. That's interesting. Also, the line of earthquakes going over to Veracruz from Oaxaca and Chiapas border. And if I went back 3 days, because he got a 2, that 5.2 dropped off. It was right here. So interesting how you see a line of quakes. It's some of these things like, wait a minute, what? You can see a lot of activity. Here's that swarm. The reason why we talk today about these volcanoes is because this is in that volcanic arc, right? Comes out of here, Puerto Vallarta, all the way across over to Veracruz, right? That's right there in the
There was
middle.
a fair amount of damage from the Guatemala quake near Guatemala City.
Yeah, I heard that. I don't know how much damage it was.
Lynched 5 guys who were robbing places too.
Oh, good. Hey, South America, man, they just blast your ass. You pull over on a motorcycle and want to rob somebody of their purse or whatever, and they pull out a gun. Boom, you're dead. Whatever.
Wow.
It's not playing games. I've seen it more. I've seen more people die robbing somebody down in South America than anywhere else. It's like, wow, no doubt. But you can see right here, this is the area of interest that we're going to be paying attention to. That's what's that little volcano called right there in Mexico? Paracutin, yeah. And here's the volcanic art. That's Central America anyway. But I hope you find this interesting, and if you have anything you'd like to add, or you want to be on one of these rabbit holes, feel free to shoot me a line at JSL discussion singular. And if you'd like to add to it, or if you'd like to comment in the chat there, you can do that. I hope to continue these rabbit holes. We're getting technology worked out. you know, um, for the most part, it's okay. I think I just got to change out the mic. It's got a lot of noise. I hear it. I don't know if you all hear it. And I think we balanced the thing out. And the crash, that was due to OBS. No fault of mine. Just when it locks up like that, it happens. Anything else you want to pop up or bring up or close on this? Or
No, I can't think of anything else. Plus, I'm hitting the wall and getting very tired like earlier today.
Yeah. Well, you had a headache today too. I was a little concerned with that.
But it's way too humid here again. It's been nice and dry for 2 days, but now it's going back the other way. I don't know. So I feel pretty tired.
So could that area break apart into pieces? What area are you referring to, Eden? If you'd like to be on twitch.tv/Joystick Live, that's where our live chat is at. I'm sure there's live chat everywhere. Volcanic Arcs. Maybe. I'm not sure. It's interesting how that volcanic arc is inland, isn't it? All the way over from Gulf of America, all the way to the Gulf of California. Very interesting how it's at that angle. I think that's pretty far out to me. And I would like to know a little bit more about it. I find it super, super interesting. As I go on the Rumble and see. Whoa.
Well, I think it's part of an east-west lineament because I traced fires along it one other time, and I went the whole way around the world on that same line that matches that
Right.
Mexican volcanic belt. And it was all burnt there, all the same, like all within a few months' time, and it went right around. And you could trace the wildfires and the quakes here a couple of years ago.
Right.
And it just so happened it lined up with that. And I went the whole way around and traced it the whole way around. And I can't remember if it lined up with something in China, I think it did. And there was wildfires and quakes in China on the same line. Because I think the Trans-Mexican volcanic belt lines up with southern China, I think.
Mm-hmm.
I think.
Well, you're talking about lineament speaking wise, right?
Yeah.
Yeah.
So I went like the whole way around, and there was big fires in Mexico all along that. Up in the mountains.
Okay.
But volcanoes.
Right on.
I don't remember what year it was. A couple of years ago at least.
Well, all right then. Is there any other questions?
Yeah. Bedtime for me too.
Hey, maybe tomorrow. Maybe tomorrow I'll have questions, eh? Good night, everybody, and thanks for being here. Us old folks go to bed at 8:30. It's already 9 o'clock, and well, it's 1 o'clock Canucks side of the world. But this is the only time he can do it. I'd have it earlier, but he's got to do it at this time because of his schedule. How'd your guys do? Oh, no, it's who won the All-Star?
They're playing right now.
Still?
Well, they're in Sacramento. They're
What?
playing the A's right now.
No, it's All-Star break.
No, there's still games through Sunday. All-Star break starts Monday.
I just saw it. Oh, and that was a previous All-Star. All right. How your boys doing then?
They're losing 4-2 right now.
Oh, shoot.
But the Yankees lost. Tampa Bay lost earlier. But they're into the athletics bullpen now. Athletics bullpen first.
Hey, the Angels are playing the D-backs, and they're 6-3 in the 8th inning. So that's all right. And you heard old Trouty, he's at 392 or 94 home runs.
Yeah.
Yeah. You've heard that?
Yeah. Well,
he's the.
There was 2 that were supposed to go to the All-Star game from the Angels, but then they pulled out.
Well, good.
Trout and Cucci, I think, was supposed to go.
Yeah, hey, that new guy, Solomon, I forget what his name is. Batters, Soler. He hit a monster home run the other day. Shoot, that thing, it went into orbit.
Yeah, well, he's always been a big home run hitter because he hit 40-something some year.
Oh, yeah. Well, he's hitting 211, so he ain't doing too well.
Oh, yeah, well,
Trout's hitting 232. He's what is it? Three at bats, 1 run, 1 hit, 2 ribbies, 1 base on balls, and 1 strikeout. So he's scoring runs, The D-backs are up right now, top of the 8th. Or is it the top of the 9th? They're in Angel Stadium, so yeah, top of the 8th.
Yeah, he's taking out Gosman. I think Tommy Nance. Nance is terrible.
I couldn't hear you.
Yeah, the Jays just took out Gosman, so they're taking in Tommy Nance. Nance is terrible. But Blue Jays are going to have a whole bunch of bullpen. Straight to the bottom of the barrel. Bullpen pitchers.
How do you throw a 91-mile-an-hour changeup? It's too fast. Crazy.
Let's throw like 100 changeup.
Yeah. Let's look at the standings here. Here we go. The asshole cheaters are still in first place. Looks like they're up 3.5. They're tied with the Mariners, though. Nope, Mariners are 6 back. Sorry. Angels are 9.5 back. Oh my God. Athletics are 17.5 back. And the cheaters are still cheating. Blue Jays are 2.5 up. The Yankees are next, 2.5 back. The Boston is 4.5 back. Tigers, Tigers going to win their division. Oh my God. They're 11.5 in front. We're halfway through the season now, everybody. Halfway through. And the Tigers are 11.5 out front, 59-37. That's really not saying much. The assholes are 56-39. Jays are 55-39. So the Tigers 59-37. I guess the Twins, the Royals, the Guardians, and White Sox are all just terrible teams. Well, they're all about break even, except for the White Sox. Oh my God, they're 27 out. They just folded in. The Mets 55-41. They're a half a game in front of the Phillies. Marlins are 11 games out of there. Chicago is in first by a game. Milwaukee Brewers are a game out. St. Louis is 6.5 after them. The Dogs are 4.5 up. Padres are right behind them, 4.5. Frisco's 5 after that. And the D-backs are 10.5 beyond that. So that's your standings. And Trump's going to put 30% tariff on the EU and Mexico. He didn't like something from Mexico. They pissed him off.
Yeah, 35% on Canada.
I don't know what they're doing. I think people are trying to go through Mexico, ship to Mexico and then get across the border. I think that's what it's about. Yeah.
Well, same Monroe isn't on that. Trump gets going on the tariff thing. So until it gets back to everything going off in Iran, they're both together.
Hey, China's getting involved over there. I wish they wouldn't.
Well, they won't have any oil from Iran if Iran gets blown up.
But the enforcers are on right now. So drone explodes on Crimean bridge. Massive battles across Syria, breaking more. Oh boy. Also, tomorrow I'll play Seattle Bedrock, the third in the series. Very interesting series he's trying to look up for. That's Nick Zentner. He's going to do his TV show, and interesting how the basement rocks, and then how the other stuff got folded. It's been some really interesting discussion up there on the island of Vancouver. So be aware. Yeah. Kilauea exploded at 28th time. We're waiting for the 29th. Yeah.
Fall asleep, fall in the chair. So I'm like staring at my phone, but getting sleepier.
Mm-hmm. All right, brother. Thank you so much.
Good night, everybody.
Yeah. Good night, everybody. Love you, Canut. Good night, buddy.
Yep.
Good night, everybody.